So I'm on page 23 of your packet, so if you want to open up to page 23 and you can take notes. I'm looking at number 1, and it says to determine if the following function is continuous at x equals 3. So remember, when we're talking about continuity about any point, the first thing that I like to usually start looking at is the limit coming from the left and the limit coming from the right and seeing if they're the same. Now here, this is the limit coming from the left because these numbers are less than 3. So the graph is coming from the negative direction. And here, this is the limit coming from the right because these are values that are greater than 3. I understand they're also equal to 3. We'll deal with that in a second. So my limit from my left has to equal my limit from my right. So remember, all we're going to do is we're going to plug in the number 3, and we're going to see what we end up with. So if I plug in 3 into the top part of the piecewise function, I'm going to get the square root of 16, which is 4. And if I plug in 3 into the bottom part of the piecewise function, I get 16. Oh, I'm sorry, I'm plugging in 3. 3 squared is 9 minus 5, which is 4. So since these guys are the same, then we know that the limit as x approaches 3 of this function exists, and it's actually 4. So that's the first step in proving continuity. The second step in proving continuity, remember, is that we have to find f, in this case, of 3. Well, f of 3 is right here because this is where x is equal to 3. And we know that f of 3 is 4. Then the last part of continuity is that the limit, in this case, as x approaches 3, of f of x would have to equal f of 3. Well, we already know right here that the limit as x approaches 3 is 4. So we know that this is 4 right here. And we also know that f of 3 is also 4 because here's x equals 3. And when we plugged in 3 here, we ended up getting 4. So then we can say that this function is continuous. All right, let's look at the second one. So this one is actually assuming that the function's continuous, and we have to find k. So we're going to plug in 3 here. So that's going to give me 9 minus 1, right? 9 minus 1, which is 8. Now just FYI, not that it's a big deal, but there really should be a comma right in here. I didn't put it in there. Okay, and then I'm going to also plug in 3 into the bottom part of the piecewise function. So that's going to be 2 times k times 3, which is 6k. Now, if we are going to assume continuity, then we have to say that these guys are equal to each other. Because, just quickly, this is the limit coming from the left. This is the limit coming from the right. These values should be equal to one another when we plug in 3. That way the limit exists. Then this would be f of 3 because this is where x is equal to 3. Okay, and then we're just going to, at this point then, take 6k, set it equal to 8, divide out our 6, and let's make sure that we simplify that. So that's going to be 4/3. All right, number 3, it says determine where the function is discontinuous, if at all. So I noticed that these two guys right here both contain 0 in their domain. So I'm going to plug in 0 and see what I end up getting. Well, when I plug in 0 into the top part of the piecewise function, I get 0 over 3, which I know, oops, that should be a 3, which I know is 0. Okay, now if I plug in 0 into the middle part of the piecewise function, I get 0 squared minus 3 times 0, which is also 0. So just quickly, this is my limit coming from the left, because that's less than 0. Here's my limit coming from the right, and this is f of 0 because this is where x is equal to 0. So I know that that top part, we have a continuous function at x equals 0. All right, let's try the bottom now. So I'm going to look at these two bottom guys, and I see that they contain 2. So let's plug in 2 into the top, in the middle part there. So I'm putting 2 right in here, okay? And when I plug that all in, I get 2 squared minus 6, which is equal to negative 2. Now I'm going to plug in 2 to this bottom part right here, and I get 2 squared minus 8, and that whole thing is over 2. And when I reduce that, that is also negative 2. So once again, like the first two groups, these second two groups, those are also continuous. Okay, now, so you can see that we have this function is continuous at x equals 0, okay? And we can see that here as well, we have the limit coming from the, let's see, as x approaches 2, this is the limit coming from the left, and this is the limit coming from the right. So we do have that the limit coming from the left and the limit coming from the right, if we look right here, are both negative 2. So we know the limit exists. Here's the difference. Where's x equals 2? There is no x equals 2. So even though the limit coming from here, this is the limit coming from the left of 2, and this is the limit. So even though these two guys right here are the same, all that proves is the limit from the left is equal to the limit from the right. We don't have f of 2. There isn't one because we have no equal to. So determine whether f of x is continuous. It's not. And it's not because f of 2 does not exist. Alrighty, so we're again back to proving whether or not something is continuous. So I am looking up here at the top part of the piecewise function in number 4, and this is the limit coming from the right, and this is the limit coming from the left. So I'm going to start by plugging in 2 there. So when I plug in 2 to the top, I get 3 minus 2, which is 1. And I'm going to plug in 2 to the bottom here, and I get 2 over 2, which is 1, plus 1, which is 2. Okay, so do you see that those numbers end up not being the same? So then I know the limit of this function f of x as x approaches 2 does not exist. Therefore, not continuous. Now, I don't know if any of you noticed, but there's no equal to here, and there's no equal to here. So f of 2 also does not exist. So you could have picked that up right away and said, oh, well, wait a minute. This function f of x can't be continuous because there is no value at x equals 2. Okay, so that's just one other option if you want to look at it from that perspective. Okay, number 5. Now it says to state whether or not the function is continuous. I want to talk a little bit about this. Guys, all this really means is you've got a point, and that point is 2, 2. Okay, because they're telling you when x is 2, y is 2. So that's the point 2, 2. So that's really f of 2, if you want to think about it that way. Okay, so we know, and I'm going to stick that off to the side over here, that f of 2 is 2. Okay, so at least we have that. Now I'm going to tackle the limit from the left coming and the limit from the right. Well, here's the limit coming from the left because those are numbers less than 2. Here's the limit coming from the right. Those are numbers greater than 2. So let's just plug in an x value of 2 and see what we get. All right, so over here, if I plug in 2, I get 3 minus 2, which is 1. And over here, if I plug in 2, I get 2 over 2, which is 1. So you can see here that the limit of the function f of x as x approaches 2 is 1. All right, now remember the last rule for continuity. The last rule for continuity states that the limit of the function has to equal f of 2. Let me say that again. The limit of the function, in this case, as x approaches 2, has to equal f of 2. And if you look at that, that does not happen. So these guys right here are not the same. So the reason why this function is not continuous is because f of 2 does not equal the limit of the function as x approaches 2. Okay, so this is not continuous. And I should say, even though I did say it up here, these guys, this one's not continuous either. Okay? All right, so let's look at number 6. Now, I'm going to take a quick peek here, and I do notice I have limit coming from the left. This is a limit coming from the right, and look, I do have x equals 1. All right, so I'm going to plug in 1 here, I'm going to plug in 1 here, and let's see what we end up with. So if I plug in 1 into the top part of the piecewise function, I get 1 over 0, and that is undefined, right? It is not indeterminate. Indeterminate is 0 over 0. Okay, well, let's keep going, and let's see what I get in here when I plug in 1. When I plug in 1 here, I get 1 minus 2 plus 5. And that ends up giving me 4. Well, clearly we have an issue here, right? So we would say that this is not continuous. And the reason being is because the limit of f of x as x approaches, 1, does not exist. And remember, the reason why it doesn't exist is because the limit coming from the left does not equal the limit coming from the right. All right, last one, number 7. I'm going to do the same thing. So how about now let's just pay a little bit of attention down here. Okay, because this says when x is not equal to 1. So basically, whenever x is anything but 1, negative 1 rather, we're going to use this graph. So basically, the limit coming from the left and the limit coming from the right, we would use this graph. And then this right down here is just, and then this value of 2 down here, that's just the point x equals negative, or actually when x equals negative 1, y is 2. So I'm going to squeeze that up here because I can't really get that far down on my screen. So this part right here is just really the point negative 1, 2. Okay, all right, so let's plug in x equals negative 1 here. And if I plug in x equals negative 1, I'm getting 1 minus, and then when I square negative 1, I get positive 1. And 1 minus 1 is 0. All right, so now remember what I said though. This domain right here means the limit from the left and the limit from the right. So I basically know at this point, based upon what I just did, that the limit of f of x as x approaches negative 1 from the negative direction, and the limit of the function as x approaches, negative 1 from the positive direction, both of these equal 0. That's basically what this right here is saying. Okay, now remember the next part of continuity is that you have to have a y value when x is negative 1. Well, we do. It's 2. That was the second part of the piecewise function. However, the third part of continuity is your f of negative 1, which in this case is 2, has to equal your limit, which it does not. 2 and 0 are not the same. So, therefore, we can say that this is going to not be continuous.